Okay, today what I'm going to show you guys how to do is limiting reactant problems. And the reality is, try to use some type of common sense way of thinking about this, is if you're not given the exact amount of reactants you need to produce a product, you need to determine which of the two you'd run out of first. And so I always mention, like what if you had a bunch of friends come over to the house and they were hungry, and they, you look in the fridge and you got, ham, you got some bread, and you're going to start trying to make ham sandwiches out of that. Well, you can start putting them together, and the likelihood that you're going to run out of ham exactly when you run out of bread is probably not going to happen. So whichever one of those that you run out of first will determine how many sandwiches you get. In that case, that's your product. And so that's what we have to determine. When you're given two amounts of reactants, you have to determine which one you'll run out of first, because that will then determine how much product you get. In industry, what people do is they will take whichever reactant is the cheapest. They'll add a little extra in there to make sure this reaction goes to completion, because the reality is what you predict you would get on paper, you don't actually get that, because not all the atoms and molecules hit each other. So again, like I said, they'll take a little bit, whatever's cheaper, add a little extra to make that reaction go to completion. So what we're always trying to do in these types of problems, they're giving you two reactant amounts, and you're going to have to determine which one you run out of first, and then that'll determine how much product you're going to get. I have taught these problems 3 different ways over the years. The thing I've settled on now, it possibly takes maybe a little bit more time, although if you try other ways, you can look them up on the internet. They really don't save you a lot of time, but this way it just makes you're going to get the right answer every time. The other one, sometimes people can make mistakes on some of the other ways I've taught this. This one should be kind of mistake proof, because what you're going to do is you just take each reactant, solve for the same product, and whichever one gets you the smallest answer, that's the one you run out of first, because it's going to get you the lowest amount of product. So it's a foolproof way to get limiting reactant problems correct. So let me show you what I'm talking about. First of all, we need an equation. So sodium reacts with chlorine. It's diatomic to produce sodium chloride. Again, they're 1 and 1, so again, it's not balanced. We got to balance it, so we need a 2 there and a 2 there, and that balances it. Now, take each reactant and solve for the product that you're getting. Now, if you're getting more than one product, you solve for the ones that somewhere in the problem, they're going to tell you, okay, how much of this do we get? You solve for the one that they're actually asking for. So in this case, we only have one product, so we're going to take the 6.70 moles of sodium, and we're going to solve for moles of NaCl, because again, that's the only product there, over moles of sodium. Get these numbers from the balanced equation. Again, we're in the middle step of our stoichiometry problem, so these are one-step problems. You go here, when you're going from moles to moles, you go, okay, there's 2 in front of Na and a 2 in front of NaCl, so you multiply, cross, and divide. So 6.7 moles of sodium would get us 6.7 moles of NaCl, because it's a 2-to-2 ratio or a 1-to-1 ratio. It should make sense. Now we got to take the other one. We have 3.20 moles of chlorine. We're going to calculate how much again, the product we're going to get, same thing, over moles of Cl2. Get the numbers from the equation. 1 over 2. 3.2 times 2 is 6.40 moles of NaCl. Now here's the thing. Remember what I said. You just take the 2 reactants, solve for the exact same product. Whichever one gets you the correct answer, it's giving you the smallest amount of product, which means you run out of that thing first. So the limiting reactant is chlorine. So our limiting reactant is chlorine because it gave us the smallest amount of product. And again, this way, always make sure you're going to get them right. Can't miss them if you do them like this. How many moles, the next question is how many moles of sodium chloride are produced? And so again, you can see our answer is 6.40 moles. So 6.40 moles of NaCl is produced. All right, moving on to the next one. I only have two more, but these take a while. So let's think about limiting problems. There's really no shortcuts to them. So you got copper reacts with sulfur. So CuS produces Cu2S because charge of sulfur was 2, charge of copper is 1. It's not balanced now, but that would balance it. Now, again, here's what I'm telling you. Take each of these. We've got two different reactant amounts. Take each one of them and solve for. They want to know how much copper sulfide we're going to get. So do that for each one of them. It's just two different stoichiometry problems. So 80 grams of copper. Again, remember, if you don't start with moles, you got to go to moles first. You got to get the mass of copper from the periodic table, which is 63.5 grams. Then we're going to go to moles of what we're looking for, which is Cu2S over copper. Pull these numbers again from the balanced equation. And then you're going to go to grams of Cu2S, or moles of Cu2S. And again, you look that up on the periodic table, and that is 159 grams. So multiply 80 times 159 divided by 63.5 divided by 2, you would get 100 grams of Cu2S. Notice for sig figs, I got 3 there. I got 3 in my answer. The way you count zeros at the end is you got the trailing zeros only count when there's a decimal. So you put a decimal there, that means there's 3 sig figs there right now. So now we take the other one. We got 25.0 grams of sulfur. We're solving for the same product. We're going to see which one gives us the smallest amount of product. That's the one we run out of first. So 1 mole of sulfur over grams of sulfur. Sulfur, you look it up on the table, weighs 32 grams. Again, we're going to the product there, that's Cu2S over moles of S. Again, we always get these numbers from the equation. That would be 1 to 1. And then again, we are going to grams of copper sulfide over 1 mole of copper sulfide. Good thing is once you start working on some of these, you already have these masses that you need there. And then you multiply across. 25 times 159 divided by 32 gets 124 grams of Cu2S. So again, here's how you determine the limiting. Whichever reactant gives you the smallest amount of product is the one you run out of first. And so the one that gave us the smallest amount of product is copper. So the limiting reactant is copper because it gave us a smaller amount than the other one. And that's the one we ran out of. Next question. See, there are other questions we have to answer associated. What is the maximum number of grams of copper sulfide that can be formed? Again, you have to understand that the one that you ran out of first, the one that gave you the lowest amount, that's the actual amount you would get in this reaction. You would get 100 grams of Cu2S. You don't get 124 because some of that sulfur is left over, which leads us to the next question. How much of the excess reactant would be left over? So we had 25 grams of sulfur. Some of that is left over. Now, in order for you to determine how much of the 25 grams is left over, what you have to do is one more stoichiometry problem. You have to take the limiting reactant, copper, that 80 grams of copper, and now you're just going to solve for how much sulfur it reacts with. And when you get an answer, you just subtract it from 25 because some of that 25 will never be used in this reaction. It is excess. So again, so what we're going to do, we're going to take our 80.0 grams of copper. Got to go to moles of copper over grams of copper. Again, copper weighs 63.5 grams. Now we're going to go to moles of the other reactant, and that is sulfur over moles of copper. Get those numbers from the equation there, and it would be 2 of those to 1 of those. And then grams of sulfur. We need to see how much of that reactant the copper would react with. Sulfur weighs 32 grams. So 80 times 32 divided by 63.5 divided by 2, we get 20.2 grams of sulfur that it reacts with. So the question is, what do you do? Is that the answer? That's not the answer. You go up here, you subtract the 20.2 from the original amount you had. So the 25 grams that you had, it reacted with 20.2 grams of sulfur. Subtract the 2. So you ended up then with 4.8 grams of sulfur that was left over. And again, I know that's a lot of work. That's just the nature of limiting problems. They take you a long time to do them. And now you know how much sulfur is left over there. And we're going to do one more, and that's it. You can work on them on your own. Magnesium reacts with hydrochloric acid. So we got magnesium, hydrochloric acid is HCl. I'd have to give you that. We haven't talked about how to name acids yet, but produces magnesium chloride. You have to cross the charges. That's not because it's a Brinkhoff element. The 2 is because magnesium's charge is 2 and chlorine's 1. You cross and put that together. And then hydrogen's H2 because it's diatomic. It's a Brinkhoff element. Then we got to balance it from there. So let's see. It says identify the limiting reactant when 18 grams of hydrochloric acid reacts with 5 grams of magnesium. Again, just take each one of them, solve for how much product you get. Now, the thing is, we have 2 products here, so the question is which one are we going to solve for, and then just read the question to see what they want. So go up here and look at the question. It says how many grams of hydrogen can be produced. So that's what we're going to solve for, so we can answer that question. So we got 18.0 grams of HCl. Kind of go to moles of HCl over grams of HCl. Look that mass up on the periodic table. 36.4 grams is what that weighs. Then we're going to go to moles of hydrogen, right? That's what it said we were looking for. Over moles of HCl. Again, get these numbers from the equation. That's 2 over 1. And then we're going to go to grams of hydrogen over 1 mole of hydrogen, which weighs 2 grams. So multiply that out, and you get 0.495 grams of hydrogen produced there. All right, now we take the other one, the other reactant, and 5.0 grams of magnesium. Go to moles of magnesium over grams of magnesium, 24.3 grams. And then we're going to go again to moles of hydrogen. That's what they said we're looking for as a product there. Over moles of magnesium. It's a 1-to-1 ratio there for those. And then again, the mass of hydrogen is 2 over moles of H2. Remember, we are canceling out the units every single time. Multiply across 5 times 2 divided by 24.3. And we get 0.412 grams of hydrogen. Now, you have to decide which of those then is the correct answer. Sorry about that. You got to decide which of those 2 numbers is the correct answer. And remember what I said, whichever reactant gives you the smallest amount of product, that is the reaction, or that is the reactant that you run out of first. So our actual amount of hydrogen that we will get will be 0.412, and the limiting reactant. So identify the limiting reactant. The limiting reactant again is magnesium, and the amount of hydrogen gas we get is 0.412 grams. So we're going to get, we've already solved for that there, we're going to get 0.412 grams of H2 produced. How much excess reactant then would be left over? And so we're going to take the 18, let's see, magnesium was our limiting reactant, so we're going to take our limiting reactant. So when you go, which one do I take first? It's the one you run out of completely, and solve for how much of the other reactant that's in excess. And then when you get your final answer, subtract it from the amount that you had. They said we had 18 grams of hydrochloric acid. We're going to solve for how many grams that 5 grams of magnesium would actually react with. So we're solving for the other reactant there. So go to moles of magnesium first. Over grams of magnesium, 1 mole weighs 24.3 grams. Again, every time we're getting those from the periodic table. Then if you go, what are we? We're solving for the other reactant, which was HCl. Over moles of magnesium. Get those numbers from the equation. It was 1 over 2. I'm sorry, 2 over 1. And then grams of hydrochloric acid is what we need over moles of HCl. And again, that weighs 36.4 grams. So 5 times 2 times 36.4 divided by 24.3. So what 5 grams of magnesium will actually react with 15.0 grams of HCl. That's not the answer. The question is how much was left over. You go back to the other page and it says we started out with 18.0 grams of HCl. It reacted with 15.0 grams of HCl. Subtract the 2, And that means that of the 18, it reacted with 18 minus 15, there were 3 grams of hydrochloric acid left over. And I'm going to write that in there, left over. You understand what we're talking about there. All right, that's it for limiting problems. You'll have something to work on yourself. Good luck.